Hello everyone, let's look at another medium LeetCode problem. Basically, in a binary tree, you need to find the longest univalue path. So what is a univalue path here? So in a given binary tree, this if you read the description here, the length of the path between two nodes is represented by number of edge nodes, which each node in path has same value. So basically, if each node in the path has same value, that is the longest path that you need to return. So and then size will be number of edges between the nodes. So here in this case it is 5 and but there are 5 nodes, and then there are 2 edges, so we have to return 2. Similarly, if you look at another example here, so we have 4 here, 4 here, and 4. So number of edges between all these 3 nodes are 2. So this is the longest path in this tree. In case, let's say this there are further 4 nodes in the tree, let's say here also 4, you have here also 4, then that longest path will be this one. So that is only 1 2 3, you have to return 3 in that case. But here in this example we have just have to return 2. So now let's see how we can solve this problem. So this is a bit tricky problem actually. So what is given here is, let's say this tree, if we take example here, this is a tree 1 and this is tree 2, which is example, right? Now the difference is, here we have straight path going upwards to see if it is the longest path or not, and then here in this case we root is also added as part of the path. So when we are writing a code, we need to consider both and then keep traversing upwards to determine the longest path. So we'll do a normal tree traversal technique. Basically we'll go to the left and then we traverse to the right, start from the root node, and then we keep traversing. So in this case, let's look at the right part of the tree here, which is this part. Now if once I keep traversing to the right, I will reach to this particular node, and there's nothing further tree, so we cannot traverse down further. Once I reach to the root node, I see this is there is nothing left or right here, so I'll return 0. So return is going to be my 0. Now once I go back, so it will return 0. Yeah, I reached to this particular node. Now here once I reached here, I'm going to check whether this node, is basically root node and root dot right are same. If they are same, basically the value of this node and then value of this node are same or not. If they are same, I'll return 1 as an increment, because I found the similar nodes, previous node. Now I traverse on further, go up. If now again find this node and this node value are same, so I'll return 1. Now I'll get in detail, right? Instead of just returning 1, basically I'm going to return a bit of more information. Let's say there's also here another node, let's say 3, right? So right node is 5, left node is 3, so only for the right node I'll find the match here, but left node is 3, so I'll not find the match. So in this case I'll return 0. So this is 1. So when I come here, so I'll compare, I'll take a max of 0 and 1, and then based on this max I'll return whichever is the longest path. In case let's say this is also 5 and there is also 5, so this will return 1 and this will return 2, and this in this case is 1, so I'll have 2 comma 1. So in this case the max path is 2, so this is my max path, considering this node is 5 and this node is also 5. Okay, so this is getting a bit messy here. So I will look into the other tree. Now once I'm returning all these max value between these two nodes, I'll also sum it up. Let's say this is returning, there is a match here, so this is 1, and this is also match here, this is 1. So the path is 2. So this will all store into some global variable that is your path sum, let's say. So this is 2. In any case, if this is node is also 4, and let's say there is another node which is also 4, so in this case this path sum will be updated, and then this will, so this is going to be 1 written here, 2 written here, and 3 written here. So I'll see what is the maximum value, whether path sum is maximum or the current traversal that I did which is maximum. So in this case 3 is a maximum, so I'll update the path sum as 3. So I'll ignore this current value, so this is going to be 3, right? So this is the logic. Let's look at the code now. Similar way I have implemented. So what I'm going to do is I'm going to create dummy variable, global variable, which will store the longest path sum. So here it is currently 0, and then at the end I'm returning that value only. And I have created a helper function which is the root, which is taking root as input. So when the function start, the basic condition, if it is root is none, let's say I reached here, there is nothing to return, so I'll return 0, right? Trees our traversal I'm doing left and right. Now these conditions are important that I talked about, right? There are couple of cases. So let's say this, let's look at this one first, which talks about this case. If root dot right, yes, root dot right is present, and root dot right dot value is root dot value. At this particular node, this condition will hold true, and then what I'll add right path to 1, additional 1 value, and then since this value is written 0, so this right is going to be 0, right? So 1 plus 0 is 1, and then here in this case there is nothing in the left side, so left will be 0. So I'll see what is the maximum value between the longest path, which is initially assigned as 0, and then sum of this left and right path. So this is going to be 1 plus 0, that is the maximum between 0 and then 1, which is basically 1. Now the longest path assigned is 1, and then I'll return a max of 0 and 1, which is going to be 1 again. So 1 will go back here. Again I see there is a matching, so it will add 1 plus 1, because now right which is written from here is 1. So 1 plus 1 is 2. So again I'll seek what is the max, so I'll assign 2. So maximum will be written as 2. So longest path is 2 here, that will return. Similar case here. Here I'll get left and right both values, so both will be added at 1. Here there is a match, and there is a match here as well, and then I'll add the term as a 1 plus 1 2, and then I'll assign to longest path. And then even though if I return 1 here, there's not going to be any further match, so all is going to be 0. So longest path will be always 2 here. Let's run this. Yep, all test case works fine. You can submit it. Okay, 91%. Okay guys, thank you for watching.